Hey there DevChamp. This is the third time we are sitting together to discuss Relational Database Management System. Previously we discussed types of keys in a database management system. If you have missed it out, watch the video by clicking on the link above. Link is also available in the description below. In this video, we shall discuss different types of integrity constraints in database management system. So let's do this. Well, let's first try to understand what are integrity constraints and why do we need them. If we divide the words into integrity and constraints to understand their meanings. Integrity shall mean quality, accuracy, completeness, and consistency of data. Whereas, constraints mean limitations on data. Therefore, integrity constraints refer to the fact that data remains consistent and complete after any insertion, deletion, or updation of data in the table. And all this is required to maintain the quality and accuracy of data in database. To ensure this, we need to apply different constraints on the columns of a table, such as not null constraint, unique constraint, primary key constraint, referential integrity or foreign key constraint, default constraint, and domain or check constraint. All these constraints are generally known as integrity constraints. Now, let's discuss these constraints in detail. First one is not null constraint. As the name suggests, this constraint ensures that some data is entered in the specified column, and it cannot be left empty. Without this constraint, user can insert a row in a table, without entering any data in that specific column. For example, in the example of student_data table, which we were discussing in our previous lecture. If we apply not null constraint on CNIC number column, then every time a new student record is inserted inside the table, or any student's record is updated, it will be must to enter CNIC number, and it cannot be left empty. Now, let's move to our next type of constraint, which is unique constraint. As the name specifies, this refers to the limitation on a column that data in that specific column has to be unique, which means no duplicate or redundant data can occur in that column. If we discuss the student_data table example, and we apply unique constraint on student ID column, then, this constraint shall ensure that two students cannot get same student ID, i.e. there cannot be two students having student ID equals 2. So, if anyone tries to allocate student ID equals 2 to any new student, an error shall be generated and record will not be entered. Now, let's discuss our third type of constraint, which is primary key constraint. Primary key, as we have already discussed in detail previously, needs to identify a row in a table uniquely. Which means, unique key constraint is by default applied if a column is defined as a primary key. Moreover, as we also discussed, that a column which is also a primary key cannot have a null value, i.e. it has to have some value and cannot be left empty. Which takes us to the fact that if a column is defined as a primary key, it will have unique key constraint and not null constraint applied to it, by default. So, for example, if student ID is defined as primary key of our student_data table, then it has to be unique and cannot be null. Now, if we are clear about first three types of constraints, let's move towards fourth type of constraint, which is referential integrity or foreign key constraint. If you have seen our previous lecture of types of keys in DBMS, where we discussed foreign key in detail, you would know that foreign keys are used to refer the data from some other table to our table, and it is used to connect the tables together. For example, if we look at the example we discussed previously, batch_ID from batch_data table was referred to student_data table. So, this constraint ensures that data from batch_data table cannot be altered or deleted, if it is referred to some other table as a foreign key. This helps us ensuring the consistency of data. For example, without this constraint, if data of batch_id equals 1 is deleted from batch_data table, then while fetching report of students enrolled in 2019 batch, data of students will not be available, which will cause inconsistent data. Now, moving on to our fifth type of constraint, which is default constraint. When default constraint is applied on a column of a table, it specifies a limitation on that column, which ensures that if user does not provide any value for that specific column while data insertion, deletion, or updation, then a default value provided by the programmer should be inserted into that column. For example, if we say that in student_data table, we want to store 1 2 3 4 5 6 value for CNIC number, in case user has not provided it, then we shall be needing default constraint. Now, moving on to our sixth and last type of constraint, which is domain or check constraint. This type of constraint, when applied on column in a table, ensures that only relevant type of data, which fulfills the applied checks, can be entered in a column. For example, if we wish that only data for students having batch ID greater than 15 can be entered in student_data table, then we need to apply check constraint of b_id greater than 15, and record of any student having batch ID less than or equal to 15 shall not be inserted. So, this was it regarding concept of different integrity constraints in DBMS. In our SQL series, we shall once again discuss these constraints and learn how to apply these constraints on a table in database using SQL language. If you have any questions, please post them in comments below, and we shall try to answer them as quickly as possible. Stay connected and follow the series as we dig deeper and discuss different ways to join the tables together in next lecture. If you like the video, care subscribing the channel so that you can follow the upcoming videos and share it with your colleagues, which you think can use the help we are trying to provide here. Cheers!